going to talk about colligative properties. Have you ever thought, why do we put salt on the road during the winter? That's what colligative properties is all about. Okay. Our learning target, I can explain how adding solute particles to a solvent alters physical properties like boiling point and freezing point. And I can relate these changes to the number of particles in solution, regardless of their chemical identity. Okay, so physical properties of solutions that are affected by the number of particles, but not the identity of the dissolved solute particles, are called colligative properties. What that means is if I dissolve sodium chloride, table salt, into water, those the salt ionizes, right, and becomes sodium ions and chlorine ions, but yet they still retain the properties of salt. Okay. And so what can happen with that solution then is we could have vapor pressure lowering. That's when the decrease in vapor pressure causes the addition of solute particles into a solution. Boiling point elevation, the temperature difference between solutions boiling point and a pure solvent's boiling point. So this would be similar to the salt on the roads. If you put salt on the road, right, that salt is going to increase the boiling point of the water. Okay, so another idea, pasta. If you're going to make pasta, you boil the water, but you put salt in it because you want that water to boil at a higher temperature so that you can cook your pasta. Okay. Freezing point depression. Again, this is the salt on the road thing. You put the salt in or on the road, it mixes with the water of the snow or ice, and that temperature difference goes down, right? So it has to be even colder for the ice to form. Okay, so the temperature difference between a solution's freezing point and the freezing point of the pure solid. Okay, and the last one is osmotic pressure. That is the amount of additional pressure caused by water molecules that move back across a membrane into a solution. We're not going to talk about this one really, other than just defining it. Okay, so substances like sodium chloride, they ionize in water. That means that they break apart, like I said, into sodium and chlorine ions. When they do that, and if they conduct electricity, well, most ions do, they are called electrolytes. So Gatorade is an ionized solution. Okay. Substances like sucrose, sugar, that dissolves in water but do not ionize and do not conduct electricity are called non-electrolytes. So, like sugar molecules, they're covalent molecules. You can't easily break them apart and still have them be sugar. Okay. So, if we add salt, which is the solute, to the pure water, which is a solvent, the sodium and chlorine particles will spread out in the water, blocking the heat from getting to the water molecules and lower the vapor pressure. Okay, so here are the sodium and the chlorine, and they spread out in the water, right? And so they're blocking the heat from getting to the water molecules. Okay, so the boiling point of water increases because not as many water molecules are able to escape into the air. We call this boiling point elevation. Okay, this is the one that we're the mostly going to talk about because it's the easiest to replicate. Okay, colligative properties depend on the number of solute particles in a solution. Okay, so salt is ionic, so its particles can separate. So here you have sodium and chloride, and even though they're that far apart, there's still salt. Okay, here we have sugar. Sugar is a rather large molecule, but it's just one particle. Okay, so here's a sample of a question that might show up on the test. If you put the following in order of descending effect on depression of the freezing point, okay, freezing point depression or boiling point elevation are the same, right? The colligative property acts the same. The more ions, right, the more particles, the more effective it is. Okay, so let's break these down, A, B, C, and D, into how many particles are there. Okay, so sodium chloride, we've talked about that a few times. It has one sodium positive and one chlorine minus. That's 2 colligative particles. Okay, sugar, C12H22O11, you can't break that apart. That's a covalent bond. So it has 1. That means there is 1 colligative particle. Okay? Magnesium chloride, you have the 1 magnesium and you have the 2 chlorines. Add those together, you get 3 colligative particles. And then calcium phosphate, you have 3 calciums and 2 phosphates, right? And so now I have 5 colligative particles. So if I want to put them in descending order, I just put them in order of the numbers. So D is the highest, so that's going to go first. C is the next highest, that goes second. A is the next highest, so that goes third. And B is last. So to sum it up, physical properties of solutions that are affected by the number of particles, but not the identity of the dissolved solute particles, are called colligative properties. Colligative properties include vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. Substances that ionize in water and conduct electricity are called electrolytes. Colligative properties depend on the number of solute particles in a solution.